स्टार्ट कर दिया है. Yep.
Okay. Good evening, everyone. Today we are again here to attend the second session of Design of Experiment lecture from Penal Rana. We'll be talking about Minitab. He'll explain some uses and demonstrate us how to use Minitab for designing experiments, and towards explaining the final goal of his lecture, that is responsive methodology. So, Penal, can you please take over?
Yes, yeah. Thank you, Anup. So, hello everyone. Good evening. I am Pinal Rana. I welcome you all in the second session of Design of Experiment, which is also referred as a DOE. Okay. So, let me first share my screen. So, in this lecture, we are going to see how the 2⁴k factorial design works. So in the first lecture, we have seen the introduction of design of experiment, in which we have seen that what is the design of experiment, need of design of experiment, then sources of functional variation, and at last we have seen the this two level factorial design, right? In which we have seen in which we have taken one example with two input variable, temperature and humidity, with two levels 0 and 75 for temperature and 0 and 35 for the humidity, and the response variable is the comfort level. Okay, so moreover we have seen that how to calculate the average effect of A and average effect of B, and also calculate the interaction effect of AB. And at last we have developed one regression model in which we have developed one equation. So in the first lecture, due to some reason, I was not able to demonstrate this problem in Minitab. So today I will first demonstrate the same thing in the Minitab for two level design, and then we will move to this 2⁴k factorial design and making the same problem with the complexity and add some more complexity in that particular problem, and then generalize the whole problem and try to solve that problem. Okay, so first I will show how you can use the Minitab for design of experiment. Okay, so I sent you one file. So in that file, I have created 3 sheets. One is a Minitab sheet, second is a 2⁴2 sheet, and third is a 2⁴4 factorial. So this is the first sheet from where you have to copy the data and paste it. Sorry for the. And paste it in the Minitab. So everyone follows what I am doing now. Can someone unmute himself and just say yes if I'm able to convey what I want to say? Hello?
Yes, Penal, it's fine.
Yes, we could follow you.
Okay. Now, means steps. So you need not to remember the things. So after you copy paste the things, so first is the temperature with two levels 0 and 1. Other is the humidity with the two levels 0 and 1. And this is a response that we have measured the comfort, right? So first you have to go to statistics. Then you have to go to design of experiment. And our design of experiment is the factorial design. So you have to go to the factorial design. Then you can directly analyze the factorial design. Okay, So they said that currently I am not making any tab for that. So first we have to create that tab, and after creating that particular tab, we have to analyze the problem. Okay, so I'm creating the tab now. Yes. So in this, uh, we have to first input the what are our factors. So our factor is temperature and humidity. Okay, so we have to enter, click over here C1 and C2. Once you selected these two, you have to click on select and just check once. So yeah, lower level is 0 and higher level is 1. So you have to click OK and then again click OK. So after that you have to decide the response. What is your response? So in our case the response is the comfort level, right? So we have to select comfort, then select and go to the option. So this is not required. So I suggest you can directly move to the OK. Okay, everyone is on board? Okay. So in the last lecture, we have calculated something like this only.
Just one thing, sorry to interrupt you.
Okay.
Just because we have to switch between screens, because, we have to see your thing and then go back to Minitab and then execute it. So could you just take a
Okay.
pause of a few seconds after you give some instructions?
Okay. Sure.
Just can you repeat
So
the previous
everyone
step?
can see
Sorry.
the screen of Minitab and on the right side. Sorry.
Can you
Everyone.
just repeat the previous step? I'm sorry to interrupt.
Yeah. So what we have to do, let me tell you again all the thing. Okay. So what you have to do, just copy the that eh, that I've sent the one file of Excel. You have to just copy paste over here. After that, you have to go to statistics, DOE, factorial design, analyze the factorial design. So we have not created the design yet. So we have to create it first. So I will click yes. Then we have to decide this response factors. So our factor is temperature and humidity. So after selecting C1 and C2, you have to click yes, sorry, select. Then you have to just check once. It's a low and high is 0, 1, 0, 1, okay. After that, you have to again press OK. And what is your response? So comfort level is your response. So you have to select on C3 and press select. After that, you have to click OK. Right? So after clicking OK, after clicking OK, you will get some window like this. Okay. So now I will explain what is this thing. Okay. So uh, okay, so on right side I have opened the PowerPoint that we have seen in the last lecture. So in that we have find the average effect of A, which is 6. So you can see over here this is a coefficient which and other is the effect. So temperature is our A variable, right? So temperature effect is a 6, which is we have calculated 6 over here. Second is the humidity, which effect is a 3. Now we have calculated the same effect, which is 3. And for the combined effect, interaction effect A and B, where here the value is 1. So in our case is also 1. And this B0 is a coefficient. That is you can we have calculated using this formula, which is average of all these values 0, 2, 5 and 9, right? So B0 is a 4 that we can see over here, and remaining coefficient is the effect divided by 2. So this is B1 is 6 by 2, B2 is 3 by 2, which is 1.5, B12 is AB is equal to 1, which B12 is 1 by 2, which is 0.5. And after this, we write this equation, which is called the regression equation, right? So same equation you can find over here. Same equation you can find over here. Sorry, it is in another case. Okay, I will explain how we can use this equation using different problems. So no problem for the timing. So everyone understood what is how we can calculate this table. Okay. Now another table is for the analysis of variance, which includes the degree of freedom. This is DF is referred to as a degree of freedom. So in our case, there are four different sets of experiment. One is 0, 0, other is 1, 0, other is 0, 1, and last one is the 1, 1. So there is a four different sets of experiment. So for the total, in order to calculate the total degree of freedom, we have to just subtract 1 from the total number of experiments, means total number of degree of freedom. So the degree of freedom for the total model is 4 minus 1, which is 3. And for the individual variable, we have a 2 level of each variable. So 2 minus 1 is a 1. And for the humanity is the same case, 2 minus 1 is the 1. Now I will show the adjusted SS. SS means the sum of square, and MS is the mean of square. And what is the F value and P value, that I will explain in the I explain in the later question. Okay. Now let me shift to the just a second. How can I remove more? Yeah. Okay, so I have demonstrated how we can use two-level, two-factorial design in the Minitab, and now I will start explaining the 2 raised to k factorial design for the experiment. So till now we have seen that we have only two level with a two factor. But what if we have a two level and factor is more than 2? In that case, we have to modify our equation. So how that equation will be modified, that I will explain using the example that we have seen in the first lecture. Okay, so first I will recall all the things of the first lecture, and then I will use same equation that I have used in the first lecture and extended that equation in order to calculate the all the responses and all the variable for the more than two variables. Okay, so in first lecture we have seen that we have two variables. One is the temperature, other is the humidity, with two levels 0 and 75 and 0 and 35. So lower level is considered to be a -1 and higher level is considered to be a +1. So where -1 means A low, B low, which is considered as a bracket 1, and at this particular value the comfort level is 0. Same way, higher level of A means temperature and lower level of humidity will give you the A value of A. So A is basically whatever the positive number that is in the horizontal row, you have to consider that value over here. So here A is the positive in this particular row, so you have to write A over here. And the comfort level for that particular value is 5. Same way I have created the table. In third row, the B value is the positive, so I write B over here. And in the last row, A and B both are positive, so I write A and B. So how we can create such kind of contour or figure using Minitab, that I will explain later. Okay. Now I have tried to generalize the equation that we have developed in the first lecture. So let the average effect of A, which is 5 plus 9 minus 0 plus 2 divided by 2 is which is equal to 6. So 5 is the higher level of A, so I converted into the means I have written it down in form of A. 9 is the higher level of both A and B, so I write it down as A and B. 0 is the low level of both, so I write the 1. And this I write on B. So this and whole divided by 2. So this equation can be written in a different way like this. And this n is gives the number of replication, means if the same, so means we have 4 different sets of experiment. If we conduct these 4 sets of experiment for 3 times, then this n value will become 3. If we conduct the same sets of experiment for 4 times, then this value will become 4. Same way, I will generalize this equation average effect of B in similar manner. Instead of positive A, here is the positive B, and all the A becomes negative and B becomes positive. Same way, we have calculated the at low level of B effect, which is 5 minus B, and at high level of B, effect of A is 9 minus 2, which is 7. So same way I have written over here. So 9 is AB, 2 is B, 5 is A, and 0 is 1, and whole divided by 2. So this equation I have written in the another manner. Okay. Now we will see the formula of sum of. Now we will see the formula of sum of square. So for that, first we need see what is contrast and effect of a sum square. Okay, so that thing we have over here, this bracket is considered to be a contrast. What is the unit that will I explain in the very next slide. Okay, then effect of A, for that that is contrast divided by 2 into n, where in our case there's a 2 variable, so we have to write it down 2, and n is the number of replication. For SS means sum of square, it's a contrast square divided by 4n for the 2 level variable. So in general we have to take, instead of 4, we have to take 2 raised to k, where k is the number of variable. Same way we can calculate the estimate, which is contrast divided by 4n in case of 2 variable design. Same way we can calculate the sum of square of A, B and AB. Now we need to calculate the sum of square of total. So this is a standard formula of sum of square, in which we have to square all the y value. Y is basically represent the respond. Respond is square, and this small y is represent the individual respond. Okay, this y is represent the summation of all response, and this y is represent the individual responses. This n, as I mentioned earlier, is the number of replication, and if we want to find the error, then we have to subtract the we have to first take the total sum of square, and from that we have to subtract all the value of sum of square. Okay, now this formula is basically for the 2 variable design. So how we can generalize this problem for the more than 2 variable? Okay, so this is a formula for 2 variable. So instead of 2, we have to for more than 2 variable, we have to just change this value. Instead of 2, we have to write 2 raised to k minus 1, where k is the number of variable and n is the replicate. What is this bracket value? That will I explain in the Excel file itself. Okay. Now what is the sum of square? So that is 1 upon 4n into bracket of contrast square. Same way, instead of 4, which is 2 raised to square in case of 2 variable design, in case of k variable design, it will become 2 raised to k. Same way, we can calculate the estimate, and this is a generalized formula of a estimation for any variable with 2 level. Okay, and same way we can calculate the total sum of square for k variable design. Okay, now we will see the analysis of variance but before preparing the chart for the analysis of variance, we have to create some pre-processing in the data, right? So I have sent you this Excel file. Hello, everyone can see this Excel file now? Can someone mute himself and just give me the answer? Okay, so for now we'll move further step by step. So first I will processing this Excel file little bit, and I will give you some time to download that Excel file that I have sent you in the morning and processing the same way that I'll show you here. Okay, so in the last lecture, so we have the effect of A, effect of B, effect of C, all the variables, right? So before that, let me explain one more thing. So these are two level 2 variable design. Now the 3 variable 2 level design, you just copy paste this thing over here. You need to add one extra column over here, which is new variable, which is C. Now when we design the experiment for this particular thing, there may be a chance that we may forget some combination or some treatment combination. So here I will show the best way to how you can create the treatment combination without missing any treatment combination. Okay, so what you have to do, you have to just control V over here. Now first 4, you have to just add minus, 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 then plus, 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 plus. Here is a 5, 6, 7, 8. Okay, so here we have 3 different variable with 2 level. 2 level is, one is lower level, other is higher level, and 3 different variable is A, B, and C. So what is 2 raised to, okay, so 2 raised to k means k is the number of variables, so 2 raised to 3, which will give the 8 treatment combination. So here we have get the 8 different treatment combination. Now this both negative, so it's a 1. In this case only, sorry, in first case whole 3 are negative, so it's a 1. In this case only A is positive, so I have written A. In this case only B is positive, so I have written B. In this case whole A and B, both A and B. In fifth case there is only C positive, so I will write C over here. There is A and C both are positive, so A and C. Here is the B and C both are positive, so B and C. Here is the A, B, C, all 3 are positive, so it's A, B, C, 3. Okay, so same way we can extend this thing for the 4 different variable. So that I will explain over here. So first forget this thing. Okay, now up to here we have the same variable that we have just created over here. It's a minus 1, minus 1, minus 1, plus 1, minus 1, minus 1. It's the same thing over here. Minus 1, minus 1, minus 1, minus 1, sorry, plus 1, minus 1, minus 1, same way. Okay, so after adding this 4th column, Now I will try to write in the same way that I have written for the 2 raised to 3 factorial design. Okay, so it's a all 4 are negative, so it's a minor, so it's a bracket 1 is only a is positive, so 1. So this way I have create up to 16 because 2 raised to 4 is give you the 16 treatment combination. Okay, and I have taken one more application of that, one more application, so it will become 16 into 2, so it will give us a total 32 treatment. Okay, everyone got this? Can someone please answer? Hello, everyone got this up to here? Okay, so now I will explain how we can calculate effect of individual variable, means effect of A, B, C, D that we have calculated over here, means here we have calculated manually, but if the number of variable is more and number of replication is more, it's not possible to calculate each effect of each variable manually. So I have created one Excel file in which I will demonstrate how we can use the Excel sheet to create or to design to create the design of experimental. Okay. So for this, first we have to uh, multiply this response variable with that individual effect. So our response variable is in this column. So for effect of A, we have to multiply 90 with this A variable, because we have to just consider in this particular column, we have to know the effect of A only. Okay. So response is multiplied by effect of, means level of A. Okay. Same way, I will calculate the value of P, which is responses multiplied with B. Same way, equal to responses multiplied with C. Same way, responses multiplied with B. Now we want to know effect of A and B. So it's a similar kind of case. We just need to multiply responses multiply with here. So we want to calculate the effect of A and B. So it's a effect of A multiply with effect of B. That's it. Same way you can calculate effect of A and C. Responses multiply with effect of A multiply with effect of C. I suggest everyone to download that Excel file and start solving this problem by just multiplying this response variable to that particular column. For example, in order to know the effect of A, you have to multiply with responses with A column. For effect B, you have to multiply the responses with B column. Same way for AC, you have to multiply responses with A and C. Same way you can calculate for ABC, you have to multiply responses with A, B, and C. Okay. So same way you have to continue up to ABC. So here for ABC, you have to multiply responses with A, B, C, and D. Okay, and last one is the Y square column, which is basically a square of all the response variable. So in here you have to just Y, here Y square is equal to 90, H means responses square. Okay, so everyone got this?
Yes.
Okay, so
Yes.
I suggest everyone. Okay, so I suggest everyone to write the same column that I just demonstrated you, and let me know. Uh, you have I think it's doable in 3 to 4 minutes. So meanwhile, I will also do the same task. Any doubts during while doing this? A multiply with D, same way. B responses multiply with B and C equal to responses multiply with B and D and responses multiply with C and D responses multiply with responses multiply with C and D. Done, everyone? Done, everyone? Or you need some more time?
Just a few more seconds. What is the last column? Y2?
Y2 is basically a square of this response variable. Y2 is the square of response variable over here.
Can you show it?
Okay.
Yeah, sure.
Okay.
See, this is h2 square.
Okay.
Okay. So after that, continue accept the same thing up to the 32 variable. So you will get table like this. Please let me know if you complete with the given task.
Penal, how did you calculate the SS value?
Yeah, sure. Yeah, that I will explain after. Once we
Oh,
completed all these things, then
okay.
I will explain that thing. Okay.
Okay.
So up to this, everyone can able to get it, right? Everyone is on board, right? Hello. Can I move further?
Few seconds more. Few seconds.
Okay, no problem.
Okay, move further.
Okay. So we have completed up to over here, right? We have formulated this table, this whole table effect, which consists effect of A, B, C, D, interaction effect of A, B, A, C, and all the remaining, all the variables. And it's last we have calculated the y square value. Okay. Now next task is to calculate the contrast, effect, estimate, and sum of square. Okay. So I have just explained the formula of all these four things. So contrast of any variable, which is a plus minus thing of the all the given thing. Okay. And effect of that variable is uh, contrast divided by 2 raised to k into n. In our case, now we have a 4 variable, so 2 raised to 4, it's a 16, and number of replication is 2. So contrast we have need formula 1 upon 2 raised to 1 by 2 2n into this contrast. Okay, so generalized formula is this: 1 upon 2 raised to k minus 1 into n. So in our case there are 4 variable, which means k is equal to k3. So 2 raised to 3, which is 8, into n. N is the number of replications. So 8 into 2, which is 60. Okay, so first we need to calculate contrast, and if it will if we divide contrast with 2 raised to k into n, which is 2 raised to 4 into 2, means 32. So if we divide contrast by 32, we will get sum of square of that particular variable, and at last we will calculate the estimate. So now let me move to the Excel file. Okay, now what we have to do, we have to just do the summation of all this column. Okay, so in Excel, one advanced feature is that you have to just click over here and just click over here, auto sum. So it will automatically sum the whole vertical column for you. Okay, so you know, after that you just press enter, and here's the summation of all the variable. Okay, same way you have to do for here, and same thing you can extend from here to up to end.
Pinal, can you please repeat that?
Yeah, sure. So first we need to find the contrast. Okay, so as I explained earlier, for finding the contrast we need to just summation of the all the effects of a given variable. For example, here we have a 2 level 2 variable. So in order to calculate the contrast of
Hello, Pinal. Actually, your voice is breaking, so I'm losing things in between.
Okay, so just remember this thing. In order to contrast, you have to just do the summation of this vertical column. Okay.
Okay.
That I have already mentioned in this thing, this whole thing. Actually, we are lack of time, so let me do some hurry. Okay, everyone got this contrast? Okay, now we need to calculate the effect of table and interaction of all the variable. Okay, so here is the formula. What is this formula? Effect of any variable which is contrast, means this bracket divided by 2 raised to k minus 1 into t. In our case, k is the 4 and n is the 2. So 2 raised to 3 into 2 means 16. So here we just need to divide this column by 16. Everyone got this? And for calculating the estimate, we need to divide the effect by 2. So estimate effect by 2. Why I divided by 2? From here we can see, in order to calculate the estimate, here is the 1 by 16, whereas here is a 1 by 32. So if I divide 1 by 16 by 2, so it will become 1 by 32. Okay, so directly I divided effect by 2, or you can also do that. You can take a contrast and divide by 32. That is also fine. Okay. Now we have to extend same thing for all the. Okay. Now we have to calculate the sum of square of individual variable plus total variable. Okay. So what is the formula for that? Here is the sum of square. So it's basically a square of contrast value divided by 2 raised to k into n. So in our case, 1 by 2 raised to k into n is 1 by 32, right? So we just need to do that. So we need to, for calculating the sum of, so here in the column of responses, we have to calculate the total sum of square. So it has a different formula to calculate the total sum of square. Here initially, first we calculate the sum of the individual variable. Okay, so you have to start with the second column over here. So you have to write equal to square of that particular contrast divided by 32. Okay, everyone understood? And you have to just extend this line.
Can you repeat the
up to-
formula of effect and estimate again?
Okay, so in order to calculate effect, you just need to divide the contrast by 2 raised to k minus 1 into n. So in our case, there are 4 different variables. Okay, so 2 raised to k minus 1 means 2 raised to 4 minus 1 into, we have taken two replication. Okay, this is the first application and this is the second application. So basically, in order to calculate effect, you just need to divide, means contrast, divide by 60, and in order to calculate the estimate, you have to divide the contrast by 32 instead of 60 in the effect. You have, in estimate, you have to divide it by 32. Got it?
Okay.
Okay. Now we need to calculate the sum of square of individual variable, effect of individual variables A, B, C, AC, AB, and all the interaction variable. Okay. So, and this first column means response column will give you the sum of square of total. So in order to calculate sum of square of total, we have this formula, summation of y square. So I will use formula using this Excel file. Okay, so equal to, so y square we have already calculated over here. In the last column, we have calculated the y square value, which is square of responses. Okay, so at the end we have taken the summation of all the y square value. So it's 22950. So we have to take that value minus, we have to add the value of y, means this is a formula, y square minus, means y, this y is a square of response variable, whereas this is a summation of responses then uska square. Okay, so x34 minus this value into again this value divide by 32. Okay, so I am again explaining how we can calculate the total sum of square. Okay, so everyone can see this slide. This is a formula for the total sum of square, in which this y is a response variable. Okay, so we have already calculated the value of responses, means we have already taken the value of responses and square it in the last column of our table. This is the square value of phi square, and at the end we have did the summation of all that particular value. Okay, so we have taken that value first minus, we have simply summation of we have did the summation of all the responses without square. Okay, so that is that value is 2649. So square value minus summation of responses square divided by 32 will give you the total sum of square. Everyone understood this? Or should I explain one more time? Hello? Can someone please answer? Okay, I think everyone understood this part. Okay, so this horizontal value I have written in the vertical column. That's why actually we cannot directly copy paste this value in the vertical column. So it will take more time to write all these horizontal value in the vertical column. So I already written it down for you and send it. Okay. Now we have to create the ANOVA table for this particular problem. Okay. So we have the source value. So in which we have the total sum of square that is this value, sum of A, B, D, and all the interaction, all the remaining interactions. So I have converted this horizontal row into the vertical column. That's the only thing I have. Okay, now subtract 1 from the total number of treatment combinations, remaining variable. Only two level minus 1 is the 1. So everyone get one value. Okay, for calculating the value of now for calculating error for the degree of freedom, what you have to do, you have to subtract 30, you have to take this value 31 minus subtract all the remaining value, which is sum of 1 to 1 to this ABCD last. So it will give you 16. Okay. Now what is the MS value? MS is so what you have to do, equal, you have to divide degree of freedom to the sum of squares. So SS value divided by degree of freedom. So you will get the MS value, and same value you can extend it up to the end. Okay. Now what is the F value and P value? So F is basically a ratio of two mean square value. So two mean square value means, suppose I want to calculate the value F value of total. So what I have to do, I have to take the MS value of that particular thing and divide by MS value of error. So error is basically 7.65 625. Okay, so same way you can extend the table up to over here. Okay, now one last thing is remaining, which is a p-value. The p-value will give you the probability distribution over the given domain or given the over the curve. Okay, so in Excel there is one formula or one command is there, which is capital F DIST in bracket. Here you have to first put the F value, which is this. Then you have to you will get this value over here. Okay, same way you have to continue this for this whole column, which is F value, then degree of freedom, then this error value. Okay, so same way we can complete this table. This is called the ANOVA table. Now what is the need of ANOVA table? Okay, so I will explain that. So let me take example of two car. So we have two car. One car have a average per liter, whereas the other car has a average of 30 kilometer per liter. But if you see over here, first car have a more steep curve compared to other one, which means here the variation in second case the variation is more compared to first case. So how we can able to extract this variation in the data? That variation we can know from this ANOVA table, which is also known as the analysis of variance. Now I will explain this same thing how so we need not we don't have much time to do everything every time to create such model over here. So for that we have a ready-made software which is called the Minitab. So I will now demonstrate how we can create a same table in Minitab with only few clicks. Okay, now for that you need to create another worksheet. So this is a table for that, and you just copy paste the things over here. Okay, so everyone see the Minitab page open in your desktop? Can someone please answer? We need to hurry, just 1 or 2 minute work is remaining. Okay, see now we have to follow the same procedure, or we have a different procedure too. So now we can go to state ANOVA table, then we can make this generalized linear model, then feed the general linear model over here. Okay, in here we have to select what are the response variable, then a factor, then the covariable. So our response is a C, this thing. Okay, our factor is A, B, C, and D. Okay, yeah. Now you have to just check and click OK after that. Sorry from the think there is some problem. Yeah. So here you will find only 4 responses are there, but we have created the full factorial design, right? So we just need to change from here.
Neil, sorry to interrupt. Like we are running out of time. We are already overshooting 6 p.m.
For this relay. I think some problem to do. Sorry. Yeah, yeah. 1 or 2 minutes more, not more than that. Yeah. I think follow the procedure that I have explained in the during the starting of the lecture. Then you see over there. See. Just a few seconds more. I'm not able to add this. I don't know why. So guys, sorry for the interruption, but I'm not able to demonstrate. It's not considered all the effects, but if you compare the value over here, just let me show you. See, here we have calculated the sum of square of A, B, C. So if you check your ANOVA table over here for ABCD value, and that we have created in the using the Excel file, it will be the same. Okay. So I think we are running out of time. So further thing I will explain in the next class. And sorry for taking too much time for you. Thank you.
Thank you, Pindal, for this wonderful hands-on session on Minitab. I hope we can continue it next time because it is a 30-day free trial, I guess, and you would.
Yeah.
forward your question.